All right, it's time to talk hydrocarbons. Are you ready? Remember, organic means it contains carbon bonded to hydrogen, right? So carbon dioxide, even though it has carbon, is not organic because there's no hydrogen. That's just carbon with oxygen. Okay, hydrocarbons, they're literally the simplest organic compounds. So look at the name. Hydro means it has hydrogen. Carbon means it contains carbon. So hydrocarbons have literally only hydrogen and carbon. So obviously they're organic, right? Because carbon and hydrogen. So which one of these formula correctly represents a hydrocarbon molecule? So what is a hydrocarbon? It's something that contains only hydrogen and carbon. So you see this one, look at this, oxygen. So this is a wrong answer. So how do I tell from these that are left which one is wrong? Do you remember from the last lesson, how many bonds can carbon form? 4. So around each carbon count. So here's this carbon. I have 1, 2, 3 bonds. This one's wrong. Around this carbon, I have 1, 2, 3, 4. Around this carbon, I have 1, 2, 3, 4. Ooh, this one looks right. Let's check this one. Around this carbon right here, I have 1, 2, 3, 4, 5. Wrong answer. So there we go. All right, we use table P when we are naming the number of carbons in the chain, okay? Okay, how many carbons are in the longest chain? So look for the carbons. Are they all connected to each other? Right there. So how many? Count them. 1, 3, 4. So we use the prefix "ute" to describe that. How many carbons are in the longest chain here? Well, I see a whole bunch of carbons all connected to each other. There we go. So now count them. 1, 2, 3, 4, 5, 6, 7. So we would use the prefix "hept" to describe it. Those are pretty easy. Look at this one. Slightly more confusing. How many carbons are in the longest chain? So we have options. We could go 1, 2, 3 and make that be a chain. We could go 1, 2, 3, 4, 5, 6 and make that be a chain. Or we could go 1, 2, 3, 4, 5, 6 and make that be a chain. Or one more possibility, we could go 1, 2, 3, 4, 5, 6. Okay, no matter what, I have 3 different ways that I got a big number. This one in red is definitely wrong. That's only 3. So how many carbons are in the longest chain? 6. Okay, whether I went this way, I could have gone this way, right, to get to 6. Doesn't matter. That doesn't change much. So where's the branch? That's this, right? How many carbons are in the branch? Only 1. So we would use hex to describe the chain. Oops, terrible. Hex to describe the chain and meth to describe the branch. Okay? How many carbons are in the longest chain here? Well, we have a lot of possibilities, right? I could go 1, 2, 3, 4, 5. I could go 1, 2, 3, 4, 5. Or I could go 1, 2, 3. So what's the longest? And it's easiest just for like visual purposes if the chain is like a horizontal line. So 5, pent. So where's the branch? Right there. How many carbons are in the branch? Just one. So we would use pent to describe the chain, and we would use meth to describe the branch. Okay. Let's try another one. How many carbons are in the longest chain here? So you try it out and see. First, check the one that is straight across, horizontal. Check that one first. And then see if you count another way, if you can get a bigger number. If you can't, then just leave it straight across. That's easier. Okay, it is. No matter which way I count, I'm going to get 5. Okay, so looking straight across is easier. So 5 is what? Pent. Where's the branch? Right there. How many carbons are in the branch? 2. So I would use F to describe this branch and pent to describe the chain, the longest chain. How many carbons are in the longest chain here? So I count straight across and I get 1, 2, 3, 4, 5. Now you check all the other ways and see if you could get a bigger number. So if I count this way, 1, 2, 3, 4. Well, that's smaller. That's a good sign. Now count this way. 1, 2, 3, 4, 5, 6. Oh, that was bigger. So this is my chain. Okay. And how many carbons are in that chain? 6. So where's the branch? Right there. How many carbons are in the branch? 1. So we would talk about the branch, meth, and the chain. Okay. All right, saturated versus unsaturated. Look at these two pictures. Here's something that's saturated, and here's something that's unsaturated. What do you think it means? What do you notice? What's different? Okay, give yourself a second to try to figure it out. Saturated means all of the carbon-carbon bonds are single bonds. So saturated is like full, so it means it's full of hydrogen. So the carbons have as many possible hydrogens as they could have around them. So looking right here, all single bonds, all single bonds, all single bonds. The carbons are connected by single bonds. Unsaturated, on the other hand, has at least one multiple carbon-carbon bond. That multiple bond could be a double bond, or the multiple bond could be a triple bond. So you could hear the language multiple bond, double bond, or triple bond. Do you see? Look here. Double bond, unsaturated. Double bond, unsaturated. Triple bond, unsaturated. Do you see there between carbons and carbons, right? A carbon-carbon double bond right here. A carbon-carbon double bond. A carbon-carbon triple bond. Okay? Unsaturated. That means it isn't full of hydrogens. What does that mean? Because of this double bond, I can't put another hydrogen here. And I can't put another hydrogen here because of the double bond. Because of this double bond right here, I can't put another hydrogen here. And I can't put another hydrogen here. So it means it's not full of hydrogen. So look at these pictures. Which one is saturated? So triple bond, bam, unsaturated. Double bond, bam, unsaturated. Double bond, bam, unsaturated. Oh, look, all single carbon bonds. Okay, there are some special names for hydrocarbons. So what do you notice here? Okay, so take a minute and pause the video, look at these images, look at the names, and see what you can come up with. What can you tell me? All right, so now let's delve deeper. We have table Q in our reference tables. This reference table will absolutely help you. So what do you notice here? Okay, you have a lot of information, right? What do you notice? Look at the names. Look at the note at the bottom. Look at the general formula, the name, the structural formula. What do you notice? So what do you specifically notice about the names? Hopefully you notice this. Alkanes end in ane, alkenes end in een, alkynes end in ine. Okay, hopefully you notice that. Okay, they also have different general formulas. Also, you should have noticed this, right? Alkanes, all single carbon-carbon bonds. Alkenes, what kind of bond is that? Alkynes, what kind of bond is that? Maybe you noticed that already. All right, so look at these alkanes. So let's check the math. What do I mean by that? Here is the general formula for alkanes. And down here it tells me N represents the number of carbon atoms. So CnH2n plus 2. In methane, how many carbons do we have? 1. So C1H2 times 1 plus 2. That equals CH4. For ethane, it would be C2H2 times 2 plus 2. The only thing I had to plug into this formula is right there. Okay, and that absolutely does equal this. Remember here, I don't write the 1 when I do write the formula, but for figuring out the math, you can. All right, for this one, what would I do? C, how many C's? 1, 2, 3. C3H, plug it in, 2 times 3 plus 2. 2 times 3 is 6, plus 2 is 8. Yep, there we go. All right, and last one to check, butane, C4H, how many? 4, 2 times 4 plus 2. 2 times 4 is 8, plus 2 is 10. There we go. All the math checks out. How many electrons are shared in each single bond? Do you remember? 2 electrons are shared in every single bond. All right, now let's look at alkenes and check the math. So this one is this, CnH2n, right? See it right here? So what I do is I take the number of carbons I have, that's N, and I double it. So if I take 2 and I double it, what do I get? 4. If I take 3 and I double it, what do I get? 6. If I take 4 and I double it, what do I get? 8. So if it was C6, how many H's would it have if it's an alkene? 12. Right? How many electron pairs are shared in each double bond? And here's where the language matters. Notice how this one is asking about pairs. It's 2 pairs. Each bond is 1 pair of electrons or 2 electrons. So in a double bond, there are 2 pairs. Each bond is 1 pair or 2 electrons. All right, so here are some alkynes. We're going to check the math again. So ethine, how many C's do we have? 2. How many H's do we have? 2. Does that math check out? Well, it was C2 and then H 2 times 2 minus 2. Yep, that math checks out. Let's check propine's math. How many C's do I see? 1, 2, 3. So C3H 2 times 3 minus 2. 2 times 3 is 6, minus 2 is 4. Do I see 4 H's? Yes, I do. All right, this one is C, how many? 4. H, that would be 2 times 4 minus 2. So 2 times 4 is 8, minus 2 is 6. Do I see 6 H's? Yes, I do. So how many electrons are shared in each triple bond? 6 electrons. What if it asked me pairs? It would be 3 pairs. 6 electrons, 3 pairs. 6 electrons, 3 pairs. All right, so now when we look here, what do you notice? Okay, so look, what's the same? Well, they all start with F, right? So what do you notice? Look at the number of carbons, right? Look how many hydrogens are here, then hydrogens are here, and hydrogens are here. Just see how those change. All right, but what do you notice here? So something is new. What do you notice? Hopefully you notice this, right? The other parts are the same. So bute must mean 4, right? And then ane, all single bonds. Look at all those hydrogens. Ene, I've got a double carbon-carbon bond. Less hydrogens. Ine, I've got a triple carbon-carbon bond. Even less hydrogens. Okay, so now let's look here. What do you notice? Well, that was butane again, but what? There's a number 1 here and a number 2 here. What do you think that means? What do you think that indicates? It's this. It's this. And we'll talk about that some more. All right, that was a lot of content, but hopefully that helped and you learned something new today.